Mobile electrons are the charge carriers for electric current in a metal wire, but in a solution, both positive and negative ions are charge carriers. As we see in here, positive charge carriers are moving from left to right, so direction of the electric current is the same as the direction of the positive charge carriers. But while these charge carriers, these free electrons and free ions are moving through the conductor, so they collide with one another, with each other, and they collide with the other ions, they collide with other atoms. But of course, because of this collision, there is an opposition towards their free movement. So when you look at this simulation in here, you see that electrons are moving from left to right. While they are moving from left to right, so they collide with other particles, as you see. This collision makes the motion of electrons difficult. So due to these collisions of the electrons with the atoms, with other electrons, with other ions inside this conductor, causes electron to face some difficulty to move across the conductor. So this difficulty against the motion of mobile electrons, against the motion of electric current, because of the conductor is the origin of this difficulty, is known as resistance and represented by R, resistance of the conductor. Resistance of the conductor. Every conductor has a resistance which opposes the motion of free electrons. And this resistance of a conductor across the moment of the charge carriers. These charge carriers can be, as I said, electrons, only electrons for metal wire, or ions for solutions. So this resistance of the conductor across the moment of the charge carrier, across the electric current, depends on three factors. Three factors determine the resistance, how big or how small the resistance of a conductor. So first factor is the length of the conductor. Of course, in longer conductor, electrons will collide with more atoms compared to a short conductor. That's why resistance is proportional to length of the conductor. Resistance of a conductor directly proportional to length of the conductor. So if the resistance is represented by R, proportional to length of the conductor. Now in diagram, I draw two conductors, first and second conductor. So which one is longer? Of course, second one. If I ask you the question, which conductor has greater resistance, you can easily answer my question, because the one which is longer is the second one. Second conductor will have a big resistance. First conductor has a small resistance, because first conductor has a shorter length, second conductor has a longer length. As length increases, resistance of the conductor increases. Second factor is cross-section area of the conductor. Cross-section area means thickness. If conductor is thicker, so resistance is smaller. Resistance is inversely proportional to cross-section area of the conductor. Area, if we represent area by capital A, resistance is inversely proportional. Inversely proportional means 1 over area. So this is thick conductor. This is thin conductor. Thin conductor has a smaller cross-section area. Thick conductor has a larger cross-section area. As cross-section area increases, resistance decreases. You can in fact predict why. Think about two doors in your classroom. One door is small, the other door is big. So through which door student can pass easily? Of course, large door. It's similar. Thin resistor will have a big resistance, but thick resistor will have a small resistance. So don't forget this in chapter 5, section 3. What questions about this? So thick resistor will have a small resistance, but thin resistor will have a big resistance. And resistance is inversely proportional with the cross-section area, thickness. Third factor is the type of the conductor. Resistance changes with types of the conductor. For example, aluminium and silver. There are two types of conductor. I give example. Silver is a better conductor than the aluminium. So that is why aluminium has a big resistance, and better conductors must have a smaller resistance. Smaller resistance means better conductor. Big resistance means worse conductor. Worse conductor. Silver is a better conductor than the aluminium because silver has a smaller resistance than aluminium. So this factor, which depends on the type of the conductor, is known in physics as resistivity and represented by rho. This symbol is rho. As resistivity increases, resistance increases proportionally. So resistance is proportional to resistivity of the conductor. So now I'm going to show you a table which gives some examples, some numbers for resistivity of different materials. For example, in this table you will see that resistivity is put from smallest to the greatest. So from up to down, resistivity increases. So silver is best conductor because its resistivity is smallest, 1.59 times 10 to the power negative 8. Copper is the second best, but its resistivity is greater than silver. Aluminium is third best because its resistivity is greater than copper. Then tungsten, iron, platinum, lead, mercury, nickel, and others. So by checking at the resistivity of the material, type of the material, we can understand which material, which element is a good resistor. So three quantities determine the resistance of a conductor. One of them is the length. Second one is the cross-section area, which is called thickness. Third one is type of the conductor, which is indicated by the resistivity. So now R will be given or determined by these three quantities. That's why I am going to now give a equation which is used to calculate the resistance of a conductor. Resistance of a conductor across the moment of the charge carriers depends on three factors. One of them is the length. Resistance is proportional to length, so length must be in numerator. Second one is cross-section area. Cross-section inversely proportional. Cross-section area must be in denominator. Third one is the resistivity rho, so which depends on type of conductor. It must be also numerator. So equation for calculating the resistance of a conductor is rho times L divided by N. A, which is L length of the conductor. A is the cross-section area of the conductor, which is meter squared. Rho is the resistivity. It's a constant depending on type of the conductor. And R is the resistance of that conductor, electrical resistance of a conductor. Its unit is ohm. Unit of the resistance is ohm and symbolized by omega, this symbol. So any questions till now? Everything is clear?
I understand resistivity.
Resistivity is, as I said, different materials have different resistance. And resistance depends on the type of the conductor, okay? This type is explained by a quantity which is called resistivity. So resistivity, if this number is a big number, so it is worse conductor. If this number is small number, it's a good conductor, resistivity. So every material has its own resistivity constant. For example, what is that number for silver? 1.59 times 10 to the power of 8. This number never change. What is resistivity for copper? 1.68 times 10 to the power negative 8. What is resistivity for aluminium? 2.65 times 10 to the power negative 8. What is resistivity for iron? 9.71 times 10 to the power negative 8. So which one is smallest number? A number which is silver. So that's why silver is the best conductor. Which one is the greatest number in here? Which I draw in circles. So iron. Iron is the worst conductor in here. So the best one is silver in here. Worst is iron. Copper and aluminium is between them. So resistivity, as I said, determines how good or how bad a conductor is. Smaller the resistivity, the better the conductor. Electrical resistance of a conductor in a circuit is done as following. So, of course, you are not going to draw always a conductor in a circuit. So you are going to draw a symbol, a diagram, which represents the resistance. This is diagram which represents the resistance of a conductor. So you see the zigzag in here? This zigzag is representing the difficulty. So electrons are not easily moved through this conductor because of the resistance. And this zigzag represents resistance of a conductor. Resistance of a conductor. So as I said, it can be calculated by this equation, but I'm not going to do that right now because it's not our concern of calculating that. Only we should know resistance depends on what parameters. So of course when you calculate, you will get a number. Say that you made a calculation for a conductor, you got the number as 100. So 100 ohm is the resistance of a conductor, for example. Or another conductor can have another number for 50 ohm. So we represent the resistance like this and we write in here. So you are going to draw a zigzag. This zigzag represents the resistance of a conductor. And you are over it, you are going to write R and you will write what is the value of the resistance, just like this. This is how we represent resistance of a conductor in an electric circuit. All right, this is how we calculated the resistance by this equation, rho L over A. This equation, we can calculate the resistance of a conductor. But there is a way, there is a method for calculating the resistance of a conductor as well, without measuring the length, without measuring the area, without knowing the resistivity. There is a method, another method, for calculating the resistance of a conductor. This method in physics is known as Ohm's law. Ohm's law. So, how can we calculate the resistance, electrical resistance of a conductor by another way is by means of voltmeter and ammeter. So, how to connect them to an electric device we studied yesterday, previous lesson. So electrical resistance of a conductor R can be calculated by using a voltmeter and ammeter. And we know that how to connect a voltmeter to a device. For example, I will calculate, this is the conductor, and I want to calculate its resistance. To calculate its resistance, I have to connect the voltmeter between the ends of the conductor first. One end of the voltmeter must be connected, one end of the device, other end of the voltmeter must be connected, other end of the device. This is called parallel connection. But ammeter is connected in series. You should connect ammeter just before or after the device. So in here, I connected the ammeter before the conductor. So by this circuit, when I close this switch, so electric current will start from positive terminal of the battery, will move through the ammeter, pass through the resistor, and to the negative. So then I will measure a potential difference between the ends of the resistor or conductor. I will measure an electric current. After that, I am going to divide them. So measure the potential difference between the ends of the conductor by voltmeter first. Then measure the electric current I through the conductor by ammeter second. After that, divide potential difference by electric current. So when you divide potential difference by the electric current, you will get the resistance of this conductor. Symbol of resistance is capital R. Symbol of potential difference is capital V. Symbol of electric current is capital I. So R is equal to V divided I. This is one of the most important equation in physics, which is known as Ohm's law. And we will use this in chapter 6 in several places. Ohm's law. And if you divide potential difference across a conductor by the electric current passing through this conductor, you will calculate resistance of that conductor. Okay, what is unit of the resistance? We learned that it's ohm. What is unit of the potential difference? It is volt. What is unit of the electric current? It is ampere. This is also very important for 12th grade. 1 ohm is equal to 1 volt divided by ampere. Sometimes we are going to use unit conversion. So you are going to use this information for converting one unit to another one. Yani equivalent of 1 ohm is what? 1 volt divided by ampere is equal to 1 ohm. That's all a problem. Here you see a battery has a potential difference or EMF value, which is 20 volts. And it's connected to a conductor whose resistance is unknown. And when we connect an ammeter in here, we measure an electric current, which is 4 ampere. Calculate resistance of the conductor. How much is R? It's very easy because we know that if this potential difference is 20 volt, so potential difference between the ends of the conductor also must be 20 volt. If potential difference between the ends of the conductor is 20 volt, so we can use Ohm's law. Ohm's law is equal to V divided by I. How much is V? 20. How much is electric current through the conductor? Which is 4. 20 divided by 4, which is 5. 5 ohm is the resistance of this conductor. Resistance is a physical quantity which arises from the opposition of a conductor to flow electric charges. So resistance, let me write it in here again as summary. Resistance is a physical quantity, so which arises from opposition of a conductor to electric current. All right, so but there is this device which is called resistor, which produces a resistance. There are some special devices that applies electrical resistance to a circuit element. In electronic circuit, resistors are used to reduce electric current. Now, these devices are called resistors. When you look at an electric circuit, any broken thing in your home, check them, you will see several devices like this. These devices are called resistors. Sometimes students ask me, teacher, what is the difference between resistance and resistor? Resistance is a physical quantity. Resistor is this device. Yani, every resistor has a resistance. Maybe this sentence gives you what is the difference between them. Yeah, resistor is device. Resistance is a physical quantity which explains how much the opposition of this resistor to electric current. Every resistor has a specific number of resistance. Do you see the circles in here, different colors? Anybody who deals with electronic can tell you what is the resistance of these resistors. And they are manufactured at some specific certain values, like 10, like 50, like 100, like 1,000. So every resistor has a specific number, and then if you are expert about this, you can read them. A question, let's solve some exercises. A resistor of 5 ohm resistance is connected across the terminal of an EMF source of 20 volts. Calculate electric current through the resistor. Very easy. EMF source has a 20 volt potential difference. So what is the resistance of the resistor? It is given as R is equal to 5 ohm. Calculate electric current. It's very easy by using Ohm's law. So we know that resistance is equal to V divided by I. R is given, V is given, by I is the question. So cross product, change the place of I and R. I is equal to V divided by R. V is given as 20 volt. R is given as 5 ohm. 20 divided by 5, which is 4 ampere. So electric current through this resistor is 4 ampere. Another question. For the above circuit, so this one, you want to decrease the electric current in half. what must be the final resistance of the circuit? We want to decrease electric current in half. So initial electric current is 4. So initial is 4. This is initial electric current. Initial. But we want final to be half of this. So initial value 4 divided by 2. You want electric current to be 2 ampere. So what must be the final resistance? What is resistance for this case? Because it is the same circuit, potential difference of the EMF source is same. V is equal to 20 volt. So let's calculate resistance now. R is equal to V divided by I. V is 20. I is 2 ampere. 20 over 2. Resistance is 10 ohm. So this is the final value. What is the initial value of the resistance? It is 5. What happened? So now check. I initial is 4 ampere. I final must be 2 ampere according to the question. R initial is 5 ohm, but R final must be 10 ohm. So did you get the relation between the resistance and the electric current?
Yes, inversely.
Inversely proportional, yes, you got it. As electric current, as resistance increases, because it doubles, electric current is halved, divided by 2. Yeah, and electric current and resistance are inversely proportional. This is very important. Electric current and resistance are inversely proportional. Resistance increases, electric current decreases. As resistance decreases, electric current decreases. We are going to use this information in chapter 6, section 3 several times. Electric current and resistance are inversely proportional. Increasing resistance decreases electric current. Decreasing resistance increases electric current. All right. So in this example, we changed the resistance from 5 to 10. We decreased the electric current.